I've genuinely never understood why the sky is blue, or why everything isn't blue, if there's so much blue light coming in, or whatever, I don't know. Here's what I learned. Imagine being in space with just you and a light source. It's giving off light all around you. This is what that would look like. It looks dark over here and over here because there's no light coming in from over there or over there. You can only see something when there's light coming into your eye from that direction. So here we just see the light source. On Earth, you've got light coming in from the sun like this. Some of that light hits your eyes, which is why you can see the sun. Most of that light doesn't hit your eyes and you can't see it. But some of that light hits clouds and trees and stuff. The light then scatters. Some of it scatters in the direction of your eyeballs, which is why you can see the clouds and trees and stuff. And if that's all that happened, this is what that would look like. You can see clouds and trees and stuff. You can see the sun, except not in this photo, and the sky would be dark. But instead, we've got blue light coming in from an empty sky. It's a phenomenon where sunlight will scatter off the nitrogen and oxygen molecules in the atmosphere. The molecules are bouncing the photons all over the place. How often they scatter depends on the wavelength. The shorter wavelengths tend to scatter more. So out of the sunlight, which is a mix of a bunch of different wavelengths of light, we've got longer wavelengths scattering a bit, and we've got shorter wavelengths scattering relatively more, which makes more of the blue light hit our eyes from over there, so it looks blue over there. In a way, you're just seeing the air. Light bounces off of air molecules and then heads towards your eyes. Kind of like how you can see that mountain, because light bounces off of it and then heads towards your eyes. If the air scattered all the wavelengths equally, instead of scattering short wavelengths more, the sky would be gray or white instead of blue, because all the wavelengths together make white. Even things off in the distance will become blue. The mountain is so far away that there's enough gas molecules between us and it for us to see the combined scattered light. They call this Rayleigh scattering. Scattering because it scatters in all directions, and Rayleigh because people have names. But this effect that causes blue light to come in from the sky doesn't actually make everything blue, because the atmosphere isn't like a blue filter, only letting blue light pass through it. And the atmosphere isn't absorbing all the wavelengths and then glowing blue, sort of like a neon light or something. And the atmosphere itself isn't blue, like a puff of blue smoke, again absorbing all the other wavelengths. Okay, all the wavelengths are still coming in, and that light is the majority of the light. I mean, maybe because we can't see that light coming in, but we see this blue from everywhere, that it kind of seems like everything should be more blue. But that blue is just the relatively small amount that's really scattering about. The full spectrum is still striking objects and allowing for a full spectrum of light to scatter. So we can have blue light coming in from the sky without it making everything blue. But shouldn't things be more blue because of all the extra blue that's coming in from every angle in the sky? Even though it's not that much blue, shouldn't it accumulate? No. This drawing might be a little bit confusing. At least it confuses me. Bad drawing, bad drawing. Instead, let's just look at the blue light. If it's scattered like this, the light is coming in at different angles, but the amount of light that scatters is the same amount that would have been in direct light. On average, no spot is getting any more or less light, and nothing's going to be any more or less blue. But if the light scatters in all directions, like it does on Earth, then we're going to lose some of that light to space. That's why you can see the sky in space. So on Earth, we're only getting less blue light than we would if there wasn't any scattering, and everything should be less blue than they would have been above the atmosphere. But the effect seems to be small. Looking at the space people, things look about the same. The light doesn't really look more blue than the light that reaches us. Unless if we compare it to sunrise and sunset. During the day, light doesn't have to travel through that much air, and we're not losing a whole lot of blue. But when sunlight has to travel through more atmosphere and thicker atmosphere closer to the ground, so much of the shorter wavelengths have scattered away that the light that reaches us becomes orange or golden. They call it golden hour. And when the sun is even lower in the sky, the straighter shooting longer wavelengths are mostly shooting off into space, but the shorter wavelengths are still bouncing around. Some of that light hits objects, which tends to make everything blue. They call it blue hour. Here's them side by side. And here's a time lapse with inspiring music. Time lapses are great. Normal hour, golden hour. Normal hour, golden hour. Blue hour, blue hour. They're called hours, but they don't necessarily last an hour. It's like the 100 Years' War. Here's both together in the same shot. The straight shooting longer wavelengths make up the majority of direct light, and the blue light is going on an adventure and hitting spots in shadow to the direct light. Why does the sky get white near the horizon? 2 reasons. First, Rayleigh scattering. As we look down, we're looking through a longer and denser section of atmosphere, which allows for more air molecules for the longer wavelengths to accumulate. Remember, all the wavelengths scatter. The short ones scatter more, so scattered light looks blue, but only when you're close to it, because the blue light from far away doesn't really make it this far. Those longer wavelengths scatter less, but they shoot straighter when they do. So when we look through more air molecules, we start to get a greater proportion of the longer wavelengths. Looking at the horizon, we get the short wavelengths from the air close to us, and an accumulation of the longer wavelengths from the whole thing. We're getting more of all the wavelengths, so it looks more white, and we're getting more total light, so it looks brighter. The mountains just below the horizon are still blue because they're not far away enough for the longer wavelengths to accumulate. The second reason the sky is lighter near the horizon is from a different kind of scattering. Rayleigh scattering is when light scatters off of really tiny molecules like oxygen and nitrogen gas. But light can also scatter off of bigger stuff like microscopic water molecules, tiny bits of dust, pollution, pollen, and these things tend to scatter all the wavelengths equally, which means sunlight that scatters off of these particles will look white. The closer to the horizon you look, the more of these particles you're looking through, so over long distances that white light accumulates and it drowns out the blue. It's kind of like looking through an incredibly sparse fog. When light bounces off these kinds of particles, they call it Mie scattering. Scattering, because it scatters, and Mie, because the sky had a name. Rayleigh scattering and Mie scattering would also explain the colors of the sky at sunrise and sunset. You've got that golden light coming in, and it's bouncing off the air molecules or the little bits of stuff floating in the air. Although pollution and these other molecules can scatter away so much of that light that it becomes dull. Kind of like how Rayleigh scattering scatters away the blue light. Often the most beautiful sunsets are when the sky is clean and clear, allowing a strong light to come in, so it can just bounce off the clouds that are near you. The last question we're going to look at is maybe the first one you should have asked. Can you trust this place videos? Can you trust me, this guy? Just what kind of person is this man? Can we rely on anything he says? You know, maybe he understands how biased we are, that we have to help each other through and aim for ultimate humility, but secretly he keeps the YouTube plaque above his bed. So the ladies know what's up. Maybe he knows how to navigate the scientific literature and is grateful for an education that gave him that, but sometimes can't be bothered and just gets the information from a banana. He doesn't correct his mistakes. He might encourage you to examine the science for yourself, but only because he suspects you won't and hopes you will think he's reliable for saying that. Can you trust this man? Inspiring music. I have a lot to learn, but maybe one day I'll be okay, good enough. Can you trust that I will try to be a moderate and disinterested voice? Can you trust that I will find an acceptable balance between depth and understandability? Can you trust that my goal is to get as close to the truth as possible in this absurd and expansive place? I don't know, but this episode's brought to you by the Got Brush toothbrush. It's got bristles. It's got 50% more bristles than the next leading brand. 1 out of 5 dentists said, "Fuck me, is it for a beaver? It could strip the rust off a hubcap." I'm required to say, the first 10 people to use the promo code for free will get brush. Oh my god.